Okay, this is practice vector quiz 1, and this practice quiz is much longer than the real quiz. I just thought since we had the opportunity, we'd do a little extra practice. So again, this is much longer than the real quiz will be. The real quiz will have these kinds of problems, but it won't have nearly this many problems. But okay, so let's start at the beginning. Number 1, got a couple of points, and we're going to find the coordinates of the vector. Okay, so if you've done the practice work, this is so easy for you. The coordinates of vector AB are 8, -3. From -3 to 5 is 8. From 2 to -1 is -3. Or 5 minus -3, -1 minus 2. There are the coordinates of the vector. Okay, now here are V and U. This is given. So now we're going to find V plus U. All right, we just add the X's, add the Y's. Done. That's easy. 2U. 2U means take vector U, which is right here, and take 2 times each one of those. So this is called a scalar. We're just going to multiply the scalar times each piece of the vector. So that's going to be 2, -4. Done. Easy, easy, easy. The magnitude of V, remember that notation. This is problem C. The magnitude of V means the length of V. And to find the length, we square the first number. This is V now. We're doing V. Make sure you have the right vector. So we square the first number, 9. Square the second number, 4. Add them together and take the square root. So the magnitude is root 13. Now let's see, we've got a third vector here, vector U, or W, excuse me, W. So I'm going to box this in. This is the given. Okay, and now I'm ready for problem D, which says I'm going to add V plus 2W. So that will be 3, 2, that's V, and then plus 2 W's, which will be 10, -2. 2 W's, 10, -2. So I'm going to add those together, and I'm going to get 13, 0 again. 13, 0 is what happens when I add V plus 2 W's. Now E says take 3 U's. I'm on problem E. So I'm going to take 3 U's, which is 3, -6. And I'm going to subtract 2 V's, which would be 6, 4. So for problem E, we're taking 3 of these, so 3 times that, and we're subtracting 2 V's, so 2 times this. So when we subtract, we do it just like add. 3 minus 6, and -6 minus 4. Perfect. All right, now problem F has an extra step to it. It's just like the one we just did, but it has the magnitude symbol. So we need to do 2V plus U. So we're going to start by doing that. We're going to do this part right here first. We're going to figure out what 2V plus U is. So 2V would be 6, 4, and then plus U, 1, -2. So I'm going to go ahead and add those together. So that's going to give me 7, 2. So 2 V's, 2 of these, plus U, add them together, there we go. Now, I need to do the magnitude of that. I still have the magnitude to do. So when I do the magnitude, remember, I square the first one, square the second one, add them together, and take the square root. So the answer is the square root of 53. So there are quite a few steps to that problem. Go back and do it again if you lost track in there somewhere. But the final answer is the square root of 53. All right, the next one, which is G, says find a unit vector for W. Now, W is that vector right there. The unit vector is going to be the 5 and the -1, the coordinates of W, but we have to divide by the magnitude of W. So the magnitude of W is 25 plus 1, or root 26. So your unit vector is simply 5, -1, each divided by the magnitude, which is root 26. Square the first one, square the second one, add them up, and take the square root. And that's it. That's all there is to it. H is a dot product. V dot W. Well, V dot W. Oh, W. Not V dot U, V dot W. Got to keep track of that. Okay, so there we go. I think I got it right. V dotted with W. Okay, so when we do a dot product, we take X times X. So that's 15. We take Y times Y. That's -2. And we add them together. So the dot product is 13. X times X, Y times Y, add them up. That's how we do a dot product. So the last one on that front page is the same thing, only it's 2U dot V. This is I. So 2U would be 2, -4, and then dotted with V, which is 3, 2. So 2 U's dotted with V. So X times X, Y times Y, add them up. So the answer to that problem is -2. Now, the next problems are going to require a calculator. Sorry about the delay. I had to track down my calculator. So here we go. We're going to find the components now of the vector. So I've drawn a vector here. And we know this angle is 55, and we know the magnitude of the vector is 16. And we want to know the components, which, kids, the components mean X and Y. That's what we're looking for. So you remember from the note-taking that you did here, that to find the components, we're simply going to do regular right triangle trigonometry, SOHCAHTOA trigonometry. So we're going to say cosine 55 equals adjacent over hypotenuse, and sine 55 equals opposite over hypotenuse. In this triangle, this is opposite, this is adjacent. In every triangle you draw that's a butterfly bow tie, Y will be opposite and X will be adjacent. So x will always be cosine, y will always be sine, if you're butterfly bow tying. Okay, so then we're just going to multiply both sides by 16 and type it in on my calculator. So 16 cosine 55 and 16 sine 55. So my answers, the components of the vector, remember it's x and y, 9.18, I'll round to the nearest hundredth, and 13.11. Now, with these problems, you remember me talking about this before, you always, always, always have to pay attention to which quadrant you're in. This vector is in quadrant 4. Therefore, the y must be negative. All right, you're going to have to make that change, guys. You are simply going to have to pay attention to which quadrant you're in, and then make sure that you make whatever needs to be negative, negative. Remember, if you're not in quadrant 1, something will be negative. All right, let's look at the next one. There's another one. Remember, there are way more problems on this quiz, practice quiz, than there are on the real quiz. Just have extra practice here. Here's my butterfly bow tie. Here's my x and my y. So, once again, cosine 32. Cosine 32 equals x over 10. And sine 32 equals y over 10. So I'll type this in on my calculator and I'll get an x and a y. And my x is 8.48 and my y is 5.30. Now pay attention, one more step. Where am I? I am in quadrant 3, and in quadrant 3, x and y are both negative. So you have both negative coordinates for the components of this vector. If at any time I'm doing something that you're not sure about, remember, you have notes on all this. Go back and redo those sections in your notes. All right, find the magnitude and direction angle. Magnitude and direction angle. So here is the vector. I need the magnitude and I need the direction angle. Now, magnitude is easy. You've done, if you have been doing everything you're supposed to be doing, you have done about 10 zillion magnitudes. To find the magnitude, you square the first one, square the second one, add them up, and take the square root. So the magnitude of that vector is simply root 13. Square the first number, square the second number, add them together, and take the square root. Done. Now, to do the direction angle, we probably ought to draw a picture of this. So this vector comes over 2 and up 3. This would be a picture of the vector here. Left 2, up 3. Okay? Now, the direction angle, your actual answer that you're going to put down here in this blank, is this angle right here. That's the angle you're going to put in the blank, but that is not the angle you're going to find. The angle you're going to find is this one right here. So if I call this A, call it anything you want, I don't care. If I call that A, then I know the tangent of that angle equals opposite over adjacent 3/2. So the tangent of this angle is 3 over 2. So the angle is found by second tangenting 3/2. Again, you have a big section in your notes about this. Go back and review that if what I'm doing doesn't make sense. Second tangent, 3/2. So the angle A is 56.31. This turns out to be 56.31 when I type second tangent 3/2 in on my calculator. Now, if you put 56.31 as the answer, you're not going to be totally right, because the answer has to be the angle that comes around to quadrant 2. It has to be this big angle right here. So how are we going to find that angle? Well, this is 180 right here, right? This would be 180. We didn't quite make it to 180. So to find that, we're going to do 180 minus 56.31. 180 minus 56.31, which is 123.69. And if you just use your common sense, that red angle has to be less than 180, right? Less than 180. How much less than 180? 56 degrees less. So that's how we got that number. Okay, there's one more. And it's the same thing. We're going to find the direction angle, but this time our vector is 6, 1. Now, this one's actually going to be easier because if you draw 6, 1 over 6 up 1, A actually is the direction angle. Since that is in quadrant 1, whatever you get when you find A is going to be the actual direction angle. So to find that, we know that the tangent of that angle is 1/6. We went over 6 up 1 for that vector. So we will simply second tangent 1/6. And it's 9.46. So this angle is 9.46, and that is the direction angle because you are in quadrant 1. If you're in quadrant 1, you never have to make any adjustments. You never have to worry about negatives. You never have to worry about adding 180 or doing any of that weird stuff. If you're in quadrant 1, whatever the calculator says is going to be the answer to the question. Quadrant 1's our favorite quadrant. Now, what about the magnitude? Easy, easy, easy. You square the first one, square the second one, square the first one, square the second one, add them up, take the square root. Do the Pythagorean theorem. If you prefer, it's the same thing. You're going to get the square root of 37 as the magnitude. In the other practice quizzes that I have posted, you can do some of the very same kinds of problems, but the quiz that we take over this material will have exactly the same problems that we just did here, just fewer of them. Okay, good luck.